talking about addition. I mean simple addition. If I get 7 orange, I get 7 orange. Next day I get 7 orange. How much orange I have? How much orange is collected? So 7 plus 7, that is 14. So addition is nothing but how much is collected, how much I get. If I get 7 orange today and I get 7 orange next day, then I get 14 orange. So how much is collected at the end is the addition. So I don't know much mathematics. So I have 7 orange today. Tomorrow again I get 7 orange. Next day again I get 7 orange. How many oranges I have? So 7, 7, 7. That is 21 oranges I have. So the collection, what I get, whatever is collected, that comes to a term called addition. So if I have 7 orange, I collect 7 orange in a day. At the end of 5 days, the number of orange collected is 35. So 7 plus 7, 5 times, that is 30. That is addition. So addition is nothing but collection. How much is collected? So we call with a mathematical term called addition. Now, if I have 7 oranges, I get 7 orange. I collect 7 orange every day. What about at the end of 398 days? So 7 plus 7 plus 7 plus 7 plus 398. Okay, so it's difficult to add 7 398 times. So addition is bigger. Earlier addition was small. 7 5 times. So 7 plus 7, it comes to 35. What about 7 398 times? So bigger bulk addition. So it becomes multiplication. So 7 398 times. Now we will use bigger addition, a new notation we keep, mathematical notation called multiplication. So if I collect 7 orange in one day, next day again 7 orange. At the end of 398 days, I collect 398 into 7 orange. So that is multiplication. So if 7 gets added 398 times, it becomes 398 multiplied by 7. So this is multiplication. So multiplication is bulk addition. So how much is collected in a bulk? So better we go for multiplication. So there is another way to calculate the multiplication. Okay. So what about, like, I walk 5 kilometers in 1 hour. I get 5 kilometers in 1 hour. I collect 5 kilometers in 1 hour. The collection of the kilometers in 1 hour is 5. So I walk 5 kilometers in 1 hour. My walking speed is 5 kilometers per hour. So that becomes kind of a little complex to understand. I get 5 kilometers in 1 hour. I collect 5 kilometers in 1 hour. So what about at the end of 7 hours? So that will be 5 plus 5 plus 5, 7 times. That is again 35 kilometers. So at the end of 7 hours, I collect 35 kilometers. I get 35 kilometers. So that is addition. 7 into 5 into 7 or 7 into 5, that is multiplication. Same thing. We have another way of calculating addition and multiplication. So I can go with a graph, like I have a graph, and along the horizontal, that is x-axis, is r, and vertical, that is y-axis, is number of kilometers. So if 5 kilometers is the y-axis and r is continuous up to 7 hours, and I draw a parallel line to the horizontal up to 7, it becomes a rectangle. So 5 hour is the vertical and 5 kilometer is the vertical and 7 hour is the horizontal. Then it becomes a rectangle. If I calculate the area of rectangle, then also I get the addition. So addition, how much I collect, how much I get, is nothing but area in a graph. So 5 kilometer into 7 hours, if this is a rectangle, that is 30. Okay. Can we go a little more continuous? Like, I start with 0 kilometer per hour. In the sense, I start from the rest. I means at the beginning, I don't have that speed that 5 kilometer I collect in an hour. I start from the rest. Slowly, I walk, speed up, and at the end of 2 hours, my speed, collection of the walk kilometer, that reaches to 5 kilometer per hour. I start from rest in 2 hours. So if I draw in a graph, it will become a triangle. So how much area, how much kilometer I collect if I start from 0? Accelerate I increase the speed. I start walking faster. At the end of 2 hours, my speed comes 5 kilometers per hour. So at the end of 2 hours, where my speed is 5 kilometers per hour, means from there I can start collecting 5 kilometers every day. Whereas before 2 hours, the collection is increasing. First hour the collection is less. In next hour collection is more. How much distance I have collected in 2 hours? So that will become a triangle, and I have to find the area of that. So addition becomes easy when it goes for multiplication, because big addition is not possible, so we go for multiplication. Addition when it is continuous, or addition in simple manner also. In a graph which we draw and we get the area, then also we add. It's simple addition. Area calculation is simple addition. So that we'll see. So that is called integration. So it comes to calculus. So addition, multiplication, calculus. So addition, multiplication. And once we start finding the area, means calculating the addition through area, that is called integration. So that comes under calculus. So integration is nothing but a simple addition, where we calculate the addition through area. We can go for kind of complex, like I start my walking from 0, means I start from rest. I start increasing the speed the way sine wave happens. Like sine wave starts from 0. It reaches to a maximum. Then I start decreasing my speed and comes to rest again. In a sine wave, how much kilometer I have? So sine wave I can draw and just calculate the area. So that we'll see that how integration makes life easy. I can say in other words, how calculation of an area makes life easy when we go for addition. So rather than just calculating through plus and this and that, can we just find the area and we can get the addition. So addition, we talk addition 3 parts: addition, multiplication and integration. So all 3 parts that we see.
Further to the discussion, so we'll proceed on reenactment. This is reenactment. So what is addition, multiplication, and what is integration? Okay, so addition is nothing but collection of items. the way we described. Multiplication is large scale addition and integration is large scale addition. So multiplication and integration are same. Integration also supports continuous addition. It may be called regression. So simple is addition. If more big addition is there, then we use multiplication. And different form of addition is also, like multiplication is bigger form of addition. A different form of addition, it is also can be used for large scale, that is integration. It supports continuous addition. So that may not be possible through multiplication. Okay. So on day 1, I have 7 orange. I get 7 orange. How much is collected? So that is the question. How much is collected? So on day 1, the collection is 7 oranges. Day 2 collection is again 7 oranges. Day 3 again 7, again 7, again 7. So at the day 5, we have these many oranges. So I can just count it 1, 2, 3, 4, 5, 6, 7, 8, and it would come to 35. So the addition is nothing but collection. How much is collected? So day 1, day 2, day 3, day 4, day 5, I keep collecting. And at the end of day 5, I have these many oranges. If I count, it becomes 35. So this is addition. Simple. Like day 1 I have 7, day 2 7, day 3 7. So in numerical form we write like this, and this is the addition notation. Plus sign. So we can say plus plus plus, and finally it would come to 35. So this is addition. How much is collected is, we just use notation plus and then we say it is 35. We count. Addition is the most basic thing. So only thing that comes to result is we count. 7 plus 7, if I have number of oranges, we just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We count and it becomes 35. What about this? On day 1, someone gets 7 oranges. Day 2, 7 oranges. Day 3, like that it keep on going up till 398 days. If I go for numerical notation, then 7 plus 7 plus 7, 7, 7. So it is up to 398. Okay, so this is too big. We cannot just write 7 plus 7 plus 7 398 times. So we use another notation called multiplication. So multiplication notation is shorthand. Now 7 into 398. So it's a kind of shorthand. If we talk about physics, it has more energy. This has 7 plus 7 has less energy, and 7 into 398, this expression has more energy. In this much only it carries this big. So anyway, so in mathematics, if I say 7 multiplied by 399, it should be considered like this. 7 added 398 times. So 7 multiplied by 398. So this is multiplication. Multiplication is large scale addition. Now we can write like this: 398 multiplied by 7. Now we have to add it again, because there is nothing called multiplication, it's addition only. So now 7 added 8 times and it becomes 56. So 6 we have to write, 5 I have to remember. Then 7 added 9 times, so that becomes 63, and 5 whatever was remaining, so that I have to add, so it becomes 68. 8 I have to write, 6 I have to remember, and then 7 added 3 times, then 21 plus 6, 27. So it becomes 2787. This much addition is not possible. A human cannot add 7 398 times. It's not possible. So we go for another notation called multiplication. It's a dot, star, whatsoever. And now calculation happens in this way. One has to be written in one line, in next line next has to be written, and finally addition is done. And whatever is right side of the number, like if it is 56, then 6 I have to write, and then 5 I have to remember, then 9, 7 times 63 plus 5, 68, 6 I have to remember, then 7 plus 3, 3 times 21 plus 6. Now it is far easy. If I start calculating 7 plus 4, 7, 14, then 21, then 28, then 35, then 42, then 49, 398 times, it is impossible. So this is better. So bigger addition is multiplication. Can we think more? Is there, so this is one way. This is simple way of addition. This is bigger way of addition. Can there be another way of addition? So that comes into the question. So total collection is, so how much oranges got collected at the end of 398 days is 2786. Can we go for like this? Oranges collected, so 7 orange daily basis it is collected. So this vertical line is orange, horizontal line is days. So first day 7 orange got collected, second day again next 7 orange, third day again next 7 orange, fourth day 5 day. How many oranges get collected? We can find same addition by calculating the area. So oranges collected in 5 days equal to area equal to 7 orange into 5 days. Because area of rectangle is one side multiplied by another side. So this height is 7 and this is 5, it looks other way, but this is how it is. So this is 5 and this is 7. So 7 into 5 becomes 35. So 7 orange collected every day at the end of day 5, it is 35. So 35 can be achieved by multiplication, 7 into 5. 7 added 5 times, that is also 35, or area. If I calculate this area, the number of oranges collected in 5 days, that I can get. So this is another way. 3 ways we saw. One is pure addition. Another is multiplication. Same thing. Another is area. Everything is addition only. There is no funny way. There is nothing more in mathematics. It's a pure addition. When we go for bigger and complex, addition also becomes bigger and complex. Otherwise, there is no difference. Okay? A person, a human, is walking 5 kilometers in 1 hour. He is collecting 5 kilometers in 1 hour. So collection of kilometers in 1 hour is 5. So every hour, it can be said 5 kilometers per hour. Okay. So he is walking, he is collecting 5 kilometers in 1 hour. If a person walks for 7 hours, he is collecting 5 kilometers per hour, every 5 kilometers every hour into 7 hours. So kilometers collected at the end of 7 hours is again 35. So 5 plus 5 plus 5 7 times. It is same as the area. Okay. So area of the rectangle is 5 into 7. That comes to 35. So a person walked 35 kilometers. Person gets 35 kilometers. Person collected 35 kilometers. The amount what is collected is the area of this rectangle. Pretty simple. What about this? If person is walking 5 kilometers every hour for 7 hours, what about how much the distance kilometers he has collected at any point x? Any point x. It looks like 3. Okay. Any point x. X can be anywhere. X can be here. X can be here. Anywhere. So if person walks for x hours, where 5 kilometers every hour he is collecting, how many kilometers he is collecting in x hours? 5 kilometers every hour into x hours. That comes to 5 into x. That is the area of this rectangle. And can we denote it with another sign? So this is a new sign coming into. So we have now 3 signs. One is plus, another is cross. So one is plus sign, another is cross sign. I mean 2 tilted lines. This is third notation. It's a kind of snake. Okay. So snake also works continuously. Means it is not digital, it's analog. So it's like a snake. So now I can term this line as equation of the line is 5. 5 means everywhere it is 5. Wherever you go, it is 5. It is a horizontal line. It is 5. So equation of this line is 5. Okay, it is similar to like so equation of this line is in typical graph terminology, we write line as y equal to mx plus c. So here it would be y equal to 5. It's constant. There is no alteration. So y equal to always 5. There is no mx component. It's only constant plus c. So y equal to, this is in this format, 0 into x plus c or 5. Okay, so this is the integration sign. Integration sign is nothing but area. Okay, so 5 is the equation of the line and area is collected from 0 to x. That is from 0 to x. And this is the equation of line. If I know the equation of line, then from 0 to x, I want to calculate the area. I have to use this sign. From 0 to x, 5, or we can write also like this, 5 dx. Okay, dx doesn't make any sense, but it should look nice. So we write like this. This is the actual expression. We can omit 0 also. Means default is 0. Okay, so I can write like this. It is considered it is from 0. So if 5 and x is there, it means there is a line whose equation is 5 and it has to be for x distance, area need to be calculated. 5 into x if it is a rectangle. Same thing. This is another way of making addition, means calculating the area. Or we can just omit it, so that's also fine. Okay. What about this? If a person is working and from time x to time y, how much kilometers collected? Straightforward. How much kilometer collected? If he works from x to y, means x is, if he, from 0 he had started working, he worked up till x hours. From x hours to y hours, how much distance got collected? That is the area of like this. Or, so that is the full area y minus this area x. So if I want this area, then this full area up to here minus this area. If I subtract, this area comes. This area minus this area becomes this area. This is what we want. So, kilometers collected would be 5 km per hour for 5 y hours minus x hours, 5 km. So, 5y minus 5x. It would be like 5 dx y, 5 dx x minus, then it can be written like this. 5 is the line equation and from x to y. So this is the notation we have to use. If there is no 0, means it is from 0, like we saw here. If there is nothing, means it is from 0. So we can omit 0 also. But if it is x to y, means a line which has the equation of 5, in that line from x to y, area needs to be calculated. That area is the kilometer collected. That is the addition. What about this? Person is working. He started from rest. Here, at the beginning only, when we started calculating, at the beginning only his speed is there. He is working, he is collecting 5 km every year. Here, he is starting from rest. There is no speed. Now, he is increasing his speed. So, at the end of 1 km, he collected some amount of kilometers. Then he increased his speed. At the end of 2 km, his speed is now 5. So this is 5. Okay, so this is 5. This is 5. So, okay. Now, person is working, he is increasing his speed from 0 and he is reaching up to 5 km. Means, now from here onwards, okay, he may work constantly or he may grow his speed again, whatever. Now, question is, how much distance is collected up to x kilometer? So, I am saying 2 km. Okay, let it consider as x. So, person starts from rest up to x hours of time. At 0 hour, at the beginning, there is no speed. At the end of xr, its speed is continuously increasing and it reaches 5. Okay. So, how much distance he has? I think I have to rephrase. This is okay. So, I should rephrase this. Let's forget this x. So, I can bring it again. Okay, let's forget this x. Okay. Now a person is walking, he is starting from rest. At the end of 2 hours, his speed is 5. So at the end of 2 hours, he is running at he is able to collect 5 km per hour. His speed may increase. Okay. Now the question is at any x, x can be here. At any x, so that x would correspond here. Here. So at any x, if that guy is keep on speeding, increasing the speed, at any x duration, how much distance he has collected? Question is simple. He starts from rest, and at the end of 2 hours, okay, his speed is 5 km per hour. So this much distance he has collected, this much kilometers he has collected. What about total number of kilometers he has collected at any distance time x? So this much. Okay, so I mean this much. So, okay, so as per the integration rule, first we have to find the equation of the line, and multiplied by the horizontal, how much time. So here the equation of the line is 5 by 2h. Okay, you can calculate it. So 5.2h means every hour he is increasing the speed by 2.5. So at the end of 1 hour it would be 2.5. Then again 2.5. So it is 5. Again 2.5. So this is the equation of the line. So every hour, if h is 0, then it is 0. If h is 2, then it is 5. If h is 1, it is 2.5. If h is 3, then it will become 7.5. So this is the way his speed is growing. So we have to find this area. So as per the so one is finding the area by integration. So if I want this calculation, 5x, that is 5 into x. So that is the area of a rectangle. What about I have to find this area of a triangle. So distance collected is area of a triangle, where the equation of the line is 5 by 2h. This is how it is increasing. Area of triangle is nothing but area of rectangle. There is no difference. If I draw a line, like this, then this whole area becomes a rectangle, and the area of rectangle is this means width by height. So area of this triangle is just half. Whatever the area of the rectangle is, half of the area of rectangle is triangle. So I can say the area of this triangle is 5 by 2 into h into h. Okay, this is h. This is if this is h, then this is 5 by 2 by h. 5 by 2 into h. This is what we found. That is the equation. Y equal to 5 by 2 by h. This is h. Horizontal axis is x, x-axis is h. Then y-axis is 5 by 2 into h. Like if I want to calculate in kind of graph way, it would become like this. Y equal to 5 by 2 x or 5 by 2 h. Kilometer equal to 5 by 2 h. So for any h hour, the height is 5 into 2h. So the area would be 5 into 2h into h. So this is the full rectangle divided by 2. So this is the area of the rectangle divided by 2. This is the triangle area. For any x, we can replace h by x. So this should come x square by 2, 5 into 2. So 5 by 2 into h square by 2, 5 by 2 x square by 2. So this is this much kilometer in x hour this person is walking. If he is increasing its speed from rest to this way. Now I'll go for integration. So integration, we are making a integration learn. So if there is nothing, I mean constant or whatsoever, integration is x. If there is nothing, I would say like this. If there is nothing, and we integrate from up to x, then addition is x. This is what we saw in rectangle. Okay, if y, I just remove the y, then it is x for rectangle. So if it is 5, then it would become 5x. So if there is nothing, then it would become 5x. If there is nothing, it is x. If there is x, this is different. No, this is different. Okay. If there is x, then it is x square by 2. This is what we saw. If it is a rectangle, then it is x. If it is a triangle, like here we saw, it's a triangle. And in triangle, the equation includes the x-axis. If x-axis is h, then equation includes the x-axis. Whereas in rectangle, it doesn't include anything. It's a pure constant. There is nothing. But in triangle, this x-axis is added in the equation. So, if it is a rectangle, then if there is nothing, it is x. If there is x, this is the area of rectangle by 2. This is the area of triangle. So this is the rule of the integration. If there is a nothing, it is x. If there is x, it is x square by 2. So we can come up with a generic formula like this. The integration of x up to x to the power k, it would be x k plus 1 by k plus 1. Here, it is actually, it's not empty. It is x. X to the power 0. X to the power 0. X to the power 0 is 1, means it's a constant. It's same. Okay. So here it is x to the power 0. So 0 plus 1, that is x. 0 plus 1, so that is x. If it is x to the power 1, that comes to 1 plus 1. 1 plus 1, so x square by 2. I mean, through the area fundamentals, we can come up with this conclusion. So this is integration. If it is constant, then resultant would be x. If it is a rectangle, then x. If it is a variable, then it is x square by 2. If it is a triangle, then area of the triangle is area of the rectangle by 2. Okay, so this is how we proceed on the integration. So integration, why we are concentrating much? Because this way it won't work nicely when, like here it is very good. What we saw here, 398 into 7, that is a pure rectangle. It is not required that this would be a flat line, means I am getting 7 orange regularly, or I am walking 5 kilometers regularly in an hour. So speed would go up and down. At that point, this multiplication would not work. I have to go for this area approach. Now, here it is again constant, but here it is variable. Okay. So here it is variable. The speed is growing. Now the shape is not rectangle, it is triangle. It may go even complex. So we have to find the equation of this line. Equation of this line is nothing but calculating the y with respect to x. So if x is this much, how much would be the height? Y. If this is the width, how much would be the height? Okay, with that we calculate the area. Once area is calculated, we get the sum up. Okay, so rather than every time calculating the area, we can come up with some kind of philosophy. Like if it was a rectangle, this is the calculation. If it was a triangle, this is the calculation. So we can come up with a calculation like this. So if I face this kind of situation, then we can directly sum up like this, rather than going for trigonometry. So kind of shortcut. What about this? A person is working and in two hours he is coming up to 5 km per hour. What distance, what kilometer he has collected from x to y? XR to YR. Now that is the area of the green portion. This area is difficult to calculate. Okay, now we'll come with the same formula what we did here, full minus beginning. So that would come like this, full triangle up till here, minus this triangle. If I subtract these two triangles, this area would come up. That is 0 to y minus 0 to x, 5 by 2h dh minus 5 by 2h dh, 0 to x, 0 to y. Same thing. This area, bigger area minus a smaller area, that will come as x to y, 5. So now as per the calculation, we came up with a formula. That formula we can apply and it would come like this. We can just substitute the value of y and x. And so how much distance is collected, how much kilometer he walks between x hour to y hour, if that is the situation, that would come like this. Okay, so so addition, we started with simple addition, and that addition came to this stage. That person is not means it is not continuous. He is changing his speed. Okay, what about this? A person starting from 0 km per hour and he is increasing his speed. At one point, he is reaching at 1 km per hour speed. Then he is slowing down, he is tired, and slowly he is coming to rest. It is similar to sine wave. Sine, if t is the x-axis, then equation of this line is sine t. He is varying the height of this curve is varying. The equation of any line is nothing but height. Sine t is the height at t x. If horizontal distance is t, then vertical distance is sine t. That is the equation of any line. Y is the vertical line and x is the horizontal line. If horizontal line is small t, the vertical line is sine t. So the person's speed per kilometer per hour kilometer is increasing at the rate of sine t. So sine t at the 0 is 0, that is the sine function, and at the pi by 2 at a 90 it is maximum, that is 1, and at 180 degree, that is pi, it is 0. So person walked like this. He increased his speed like sine curve and he decreased his speed. How many kilometers he has walked? Okay, as per the integration from 0 to pi, this is the equation sine t dt. So just trust me, like for the xk plus 1 and by k plus 1, for the sine t, integration is minus cos t. If I integrate sine t, it comes to cos t. Cos t 0 to pi. Okay, that is minus cos pi minus cos 0. So that is means this area, the bigger area through pi and a smaller area through 0. So minus cos pi minus cos, like here we said x to y is whatever we get through y minus whatever we get through x. Whatever we get through pi minus whatever we get through 0. So pi cos pi is minus 1. So 1 minus. So he walks 2 kilometers. What about this? A person walks in sine wave. Then this is the graph I am receiving. How much he walks? So he walks 0 to 2 pi. He walks from 0 to 2 pi. sin t dt minus cos 2 pi minus cos 2 pi minus, so minus 1, he doesn't walk. I mean, the total area in kilometer is 0. If he walks up to 180 degree, up to pi in radian, then he walks 2 kilometer. If he doubles, then he walks 0. What's happening? Okay. If he walks like this, so this is how we draw graph. So this is the way we draw graph, but this is not the actual thing that is happening behind the scene. Now he is walking, the person is walking in this area. Now the graph is going in negative direction. Now this is minus 1. Means person is walking back. In sine wave, if it is positive, person is walking ahead. It is going forward. If it is negative, person reverses his direction and he is walking back. So here it is 0, no speed. Now he is walking back. And here he came back. So it is something like this. Okay. So I think I can start a new one. So it is very much similar to from here okay, so from here person is walking in this direction. Then he is walking back to the origin, to the same point. He walked and he walked back. This is what is happening. The person is walking in forward direction. After this, he started from the rest, but he started walking behind. And he came back to same position. So distance covered is 0. Actually this is 0. Okay, so 2 pi is 1 minus 1, 0 is also 1. It comes to 0. How much he walked, that's true, but how much distance he collected? Nothing. If he collected 7 oranges, he gave it back. Okay, so he is losing. Here he is gaining the kilometer. Here he is losing the kilometer. Okay, a person gets 7 orange in a day. Next day he give it back, and he has nothing, 0. Okay. Now in live session, what we'll see now is, now a person is working. Okay. He starts at Y. Okay. Initially, at the beginning only, his speed is high. That is Y. And at the end of d hours, he comes to rest and he decreases his speed constantly. A person starts at a high speed, slowly he is getting tired and he is decreasing the speed at constant rate at the distance at the d hour. D can be 2 hour, 3 hour, 4 hour. He completely stops. What is Y? Okay, if I know the distance covered, how much distance he covers, okay, a person starts from a point A and he goes to point B and he covers 10 kilometers in 3 hours, and he is not walking at constant speed. He started at a speed and the speed is reducing time to time. And when he reaches B, There is no speed. He came to rest. 10 kilometers he collected. He walked. What is y? With what speed he had started? So distance covered I know. So area I know. How much distance covered? That is 0. So equation of the line is 0 means this is 0, final point, beginning point. So 0 minus y by d into t plus y. So this is the intercept. So if I come into there is no y equal to, if we come to this equation, y equal to mx plus c, the way we talk. So mx is, x is the horizontal line, mx is multiplication, and c is the constant. If I see this in graph, then this is mx, this is m, 0 minus y by d, this is x, t, and this is y. Y intercept on the y-axis at the 0 point. So this is the equation. So for every t, this is the y. So every x, this is the y. So at the time of t 0, y is the speed. At the time of d, it would be y minus y, that is 0. So this is the equation. Now area is 0 to d, area is 0 to d. Then we integrate. So t becomes t square by 2, and here it's nothing, empty, y, and there is nothing, no variable. So that will become yt, and from 0 to d, so it becomes yd square by 2d plus yd. So we can just calculate, and y would become distance covered into 2 by d. So person had started, if I know the distance covered, I know how long he walked, then person started at the speed of y. So y is distance covered into 2 by d. Okay. So this is the result. If person starts at y speed and he reaches 0 speed at duration of d, and he walked a certain kilometer, then y is how much he collected, how much he walked into 2 by d. What about this? Now person is walking in same fashion. What distance? So he started with y, I know y. He stops at d, I know d. He decreases his speed constantly. How many kilometers he walked up to time capital T? A person starts at speed y, reaches 0 in duration of d. At duration of any time t, how much he has walked? So that is this area. Okay. Now I don't have to go calculation of this area minus this area whatsoever. I know the so I think I should put 0 here. 11. Okay, so now the area what we are thinking, this area. Now this is the equation of the line, as we said here. The equation of the line is this. The equation of the line from 0 to t, if we calculate the area, this much distance he has walked. So if I integrate, it would become like this. Then from 0 to t, okay, finally it would come to minus y t square by 2d plus yt. So this much distance he has covered. If y is the initial speed, he becomes speed becomes 0 at duration of d at any time this much distance he is covering. Okay, so we discussed about addition, simple addition. Simple addition can be more simple if it is in bulk, then we can use multiplication. Same multiplication can be used to calculate simple addition or multiplication we can use in calculating the area of a rectangle. Okay, if collection, the data collection, the collection of item is not same every hour, like he is walking 5 kilometer every hour, he is not walking 5 kilometer every hour. He is increasing his speed. At that time, okay, again we calculate the area. So integration is nothing but calculation of area. So we calculated area of a rectangle, we calculated area of a triangle, and at the end we came to this formula. That is, how much area would be? It would be like this. We use these fundamentals in sine wave also. We just calculated the area. So in sine wave, okay, so in sine wave, the calculation of area through integration is, so the way the integration of x becomes like this, the integration of sine t in similar fashion we calculate, it becomes cos t. So this is the way we calculate the area. So in lab session we talked about the speed. A person is behaving like this. Here it behaved like this. Initially he was constant, then he started increasing his speed, then he started walking in a sine wave, then he started walking decreasing the speed. Then we calculated that in this scenario, if I know how much distance he has covered, what is initial speed, if I know his initial speed, then at any time we calculated how much distance he has covered. So I have a Python program. Okay, so we have few images that we need to consider here. Okay, so I have one globe that is kind of rotating, and that we'll see that how it follows the method of integration. Okay, so it is Brasilia. Okay, so we'll try again. Satellite 520481024.jpg. Okay, so we are getting the globe. Now, if I just click a mouse, the click mouse on this window, it would start rotating and it would come to Brazil, Brasilia. Okay, so rotation is the distance. So it rotated 360 degree. It started from this location only. It started more or less here only, and then it rotated 360 degree more or less, and the starting speed is high. Slowly speed is decreasing, and when actually Brasilia comes, then at that point it is speed is zero. Very similar to this what we are talking. So it is starting from speed y, means speed is high, and then speed is decreasing, and at a certain duration speed is zero. So this is the model we are implementing. We know the distance, how much distance this globe has to rotate. So 360 degree means 2 pi radian, that is the distance. And distance we know, time we know, means we have set the time as 3 seconds or something. So distance we know, time we know, in what time it should happen. Then we calculate the beginning speed. Once we know the beginning speed, so this is how we calculate the beginning speed. Distance covered, how much distance covered? It covers around 2 pi in 3 seconds. So d is known as 3, 2 pi is the distance, and we calculate the initial speed. Once initial speed is calculated, then at any moment t, we know how much distance it should cover. So that much angle we have to rotate at any moment. So if I click the mouse, initially speed is high, slowly it is going slow. Okay. I have another one where distance is higher. Like here it is Marshall's Island, there is another. Marshall Island, and so this is different for Marshall Island, 171.1845 east, it is 7.1315. So here first we calculate. So we know the distance, we know that in 3 seconds we have to achieve. So we'll calculate y, what is the initial speed. Once we know the y, then through this formula what we have come to, through this formula, at any moment of the time t, we calculate the distance, and this is how we'll rotate the angle. Okay. Speed is higher because it has to achieve the same distance, bigger distance in same time. I can try running both. I don't know how much we can emulate it. Okay. So right hand side is Marshall Island. This is the new one, and left is this. Okay. So I'll click on both. In same time both are being achieved. We clicked at little delay, but this would be less speed, this would be high speed at the beginning. So that is the concept of the calculus. So we started with the concept that everything is addition. If addition is big, then it comes to multiplication. There is another form of addition, that is calculating the square, the area. Area becomes rectangle if the every day whatever or every hour whatever we get is constant, same like 5 kilometer area we get. Area become not constant like a triangle if the item collected is increasing time by time, so it becomes a triangle, and triangle is nothing but half of the rectangle. So whatever area we calculate of the rectangle, that we have to divide by 2, and finally we came to a conclusion that for rectangle the integration is x, and if it is x, that is triangle, it is x square by 2. So we derive a formula like if it is xk, then xk plus 1 by k plus 1. Then similar fashion we tried to find the collected amount in sin t function. So just we put a hypothesis that sin t, we can prove it also. So sin integration of sin t means the area collection of the sin t is cos t. So 0 to pi comes to 2. So this area is 2, and this area is 0 because this is person is walking here, person is walking and coming to rest, here person is walking coming to rest, and then like person is walking forward direction, and here it is walking in reverse direction. So area calculated is 0. In last session we saw that speed of a person which is decreasing coming to rest in some time, and if we know the distance covered, that is the area, then we can calculate the initial speed. If I know the initial speed, then any moment I can calculate the distance. Through that we have example of like if I need to travel less, then in beginning speed would be less, it is slow. If I have to travel more in the same time, the beginning speed would be higher, it is faster.